Hi. Section 3.7, Implicit Differentiation. The functions we have dealt with so far are defined explicitly. For example, and y equal square root of x cubed plus 1 and y equal x squared sine x. In this definition, y is on the left-hand side, and right side is a function of x, just x only. So that once x value is given, then we can evaluate y value directly. So we call it explicitly defined. Some functions are defined implicitly. As in this example, now x variable and y variable, y cubed and y and xy multiplication are combined in one side, so that x value is given. Then to find the corresponding y value, we have to solve a cubic polynomial of y. And so it is not explicitly obtained. So we say that it is implicitly defined. In general, implicitly defined functions are in the form of capital f of xy equals 0, and y is a function of x. To find the derivative of an implicitly defined function, first we differentiate the equation with respect to x, treating y as a function of x. So we treat y like some variable u, earlier you considered, and we collect terms with dy over dx, which is y prime, and one side, and solve for it. And so it is implicit differentiation is an application of a chain rule. Let's see this example. Okay, first we differentiate the equation with respect to x. So this x squared will become now 2x now, and y squared we apply x derivative, so that y is a variable, a function of x, so that first we try to make here derivative with respect to y, and now multiply y x derivative. So here that is 2y, and here dy over dx. Okay, and then minus 25 will be now 0, and right hand side is 0 again. So that here we have to solve for dy over dx. Later on we'll use this one for y prime in notation. Here now we can rewrite this one in this way: 2y and y prime equal minus 2x, by moving this to the other side, so that we can get y prime equal minus x over y. So that's the final answer. Now here, okay, we have that one. We'll consider this one more time. So here, d over dx y squared, that is the same as now dy squared and dy. Y, we'll consider y as a function of x, and we first make derivative with respect to y, and here now dy over dx. Rather than u, we are using y. So that's all. Just difference is just rather than u variable, we are using y variable. So the first part is now 2y, and second part is y prime. So that is exactly this one. Okay. Now we'll go here in some other examples. Okay, we differentiate the equation with respect to x, then now y is a function of x, so that x appears here, and as a function of x, y appear here, so that we have to use product rule, and so that 2x, for that term we make the derivative, then 2 and y, and plus now 2x, y, x derivative, which is y prime, okay, and plus, now for y squared, we have 2y, y derivative, and y, x derivative, okay, and right side, x derivative will be 1 and y prime. So here we collect the terms including y prime one side. So that is now 2x y prime plus 2y y prime and minus y prime equal 1, and this term can be moved to the other side, 2y. So here we have now 2x plus 2y minus 1 y prime equal 1 minus 2y. So we can conclude here now y prime equal 1 minus 2y and divided by 2x plus 2y and minus 1. Quite simple, right? Okay. Now for this one, we differentiate it with respect to x. Then now by using chain rule, it becomes e to the 2x and 2. So first we are making derivative with respect to 2x. Then it's the same as e to the 2x and 2x x derivative. Then that is 2. Okay. Now for right side, and we are making x derivative, but here x plus 3y. First we make a derivative with respect to x plus 3y. Then that is cosine x plus 3y. And here we have to multiply x plus 3y x derivative, which is 1 plus 3y prime. Right? Okay. So from here, 1 plus 3y prime equals same as now 2 e to the 2x divided by now cosine x plus 3y. Okay. Now we move 1 the other side and divide by 3, so we can finally get y prime equals and 1/3 of here now 2 e to the 2x divided by cosine x plus 3y and minus 1. Okay, that's the final answer. Okay, now for that one, if we apply x derivative, then for right side we have to use quotient rule. Then it may be a little bit complicated, so that we can rearrange the equation in this way. From here, for example, we multiply x plus 3y both sides, then is x cubed and x plus 3y. That is now left hand side. Okay, let's rewrite again this one. X to the 4 plus 3 x cubed y, and the right side must be 2x minus 1 minus y. So that is the equation we have to differentiate, and with respect to x. From here, now that is a 4x cubed and plus, now by using product rule, there's a 9x squared y plus 3x cubed and y prime equal 2 minus y prime. So here can get now 3x cubed y prime plus y prime equal, we move everything else the other side. That's 2 minus 4 x cubed minus 9x squared y, right? Okay, so we have y prime equal, that will be here 2, okay, top is 2 minus 4 x cubed minus 9x squared y, and bottom must be from here 3x cubed plus 1. That's the final answer. You can do the differentiation by using quotient rule for this term, but it'll be a little bit more complicated. So you can manipulate the equation so easy to handle, and then you can get the derivative much more easily. Okay. Okay. Use implicit differentiation to find the equation of the equations of the tangent line and the normal line to the curve at given point. Okay, so a point is given. Now we have to find the slope. Then we can find an equation of a tangent line, and also normal line will have the some slope, so that the multiplication with the slope of tangent line is -1, so that we can find the tangent line and the normal line. Okay, here, and we have to find y prime, and we have to evaluate it along with x equal to y equal to 3. Okay, let's do that. Okay, that is, now differentiate the equation with respect to x, then that is 2x, x squared change it to 2x, and here by using product rule, y plus now x y prime, and then here minus 2y y prime, right side equals 0. Okay, here we have, now from this one we have now, okay, that is xn minus 2y, so that x minus 2y, okay, that is minus, and y prime equal negation of 2x plus y. So we can reach at here y prime equal minus of 2x plus y over x minus 2y. Okay, now that is slope, and also it's involving x value and y value. But here we have to find y prime at here x equal to y equal to 3, so that here and y prime at x equal to and y equal to 3, that is same as minus, okay, x equal to, and that is 4, x equal to y equal 3, x equal to and y equal 3, so that 6, right? So that is now 7, and that is minus 4, so that 7 over 4 is the slope. We found here the point and slope, so that the tangent line can be written in this way: y minus y0 equal the slope 7 over 4, and here x minus x0. Now how about the normal line? That is now slope of normal line must be here minus 4 over 7, but passing the same point, so that y minus 3 equal minus 4 over 7 and x minus 2. Okay, so that's the final answer. Okay, use implicit differentiation to find an equation of the tangent line to the curve at given point. Okay, again same, we have to find y prime let's do it one more time. So we apply x derivative both sides. Then that is same as now 2y plus 2xy prime from this term, and plus now pi, and sine y will be changed into cosine y derivative times y prime. And then right side, the constant will become 0 in derivative. So we have here, now that is from here 2y and plus now y prime, that is 2x plus pi cosine y and y prime equals 0, so that we have here y prime equal minus 2y over and 2x plus pi and cosine y. Right? Okay, now we have to here evaluate at x equal to and y equal 5 pi over 2. Then now y equal 5 pi over 2, then that is okay, minus is the same, and 2 times y, which means there's a 5 pi, and divided by now x equal to, so it is 4 plus pi times, and now cosine y, cosine 5 pi over 2 is the same as, okay, now that 5 pi over 2 is the same as basically 2 pi plus pi over 2. And so that the value over there will be same as cosine pi over 2, which is 0. Okay, so we have a slope here minus 5 pi over 4. Okay, that's the slope. So we found the slope and the point is given. So the point slope form of the tangent line becomes here y minus y0, which is 5 pi over 2 equal slope minus 5 pi over 4 and x minus x0. So that's an equation of the tangent line. Okay. Okay, this is the end of the section. Now for this problem will be really challenging. Now show that if it is possible to draw 3 normals from the point to the parabola y equal x squared. Okay, we have 3 normals from this point, and 1, 2, 3, this green the lines, normal lines. Okay, now and then a must be greater than half. Okay, so from implicit differentiation, you can get from that one equal 2y and y prime, so that you can reach at that one. So here, now once the normal line at x0, y0 will be here now, the point y minus y0, and here y prime is 1 over 2y, so that is if you replace y with y0, then there is the slope of the tangent line, but the slope of the normal line will be minus reciprocal, which is minus 2y0, so that we have here minus 2y0 and x minus x0. Okay, now here for that portion here, if so that we can decide a value when y equals 0. So you are putting here y equals 0. Then, okay, I'll give you a hint for only this one. If you put here y value, y equals 0, then here now, minus y0 equal minus 2y0 and x minus x0. So divide by y0, and here divide by minus half, so that in minus 2, so that half equal here x minus x0. That means that x equal here x0. Okay, now rather than x0, okay, x0 is okay, and plus half, so that this x value will be a. So when y equals 0, the corresponding x value must be a, but a is same as x0 plus 1/2. So here for other two here normal lines, here x0 is positive, so that eventually a must be x0 is positive, which means a must be now larger than half, right? So in this way you can solve. And for part B, and here it is asking now for what value of a, okay, for what values of a are the other two here normals are perpendicular. Okay, that means that here two become perpendicular. Anyway, this slope must be -1, this slope must be 1, so that makes a 45-degree angle, and again 45-degree angle because of a symmetric, right? So here this must be -1, this slope must be 1, and along with that you can solve the problem. Okay, this is a challenging problem, but you can do it yourself. Okay, thank you.